Okay, so we're starting with the main idea here, the relationship between the actual size of something, the angular size of something, and how far away it is. So this is like a part of a circle of radius r, and if the object appears to be some angular size, and it actually is an actual size L, then we can say theta equals L over R in radians. So this is the main principle that we're going to use. Okay, so if we know the angular size of something and how big it is, we can find out how far away it is. So we're going to get theta, we're going to get L, and we're going to calculate R. Okay, so let's start with the drawing over here. Here's the drawing. It's this one right here. This is the drawing. Now, we can measure the size of things on here, but we need the angular size. So I'm going to do the following. I'm going to make an assumption that this was drawn by a human, which is probably true. And so if you take a piece of paper like this and you hold it at arm's length, I'm going to assume that's how it looked to the person drawing. So that would be like here. We could say, sorry, it's kind of hard to see the camera. Okay, so here's the person, here's the paper. So this is, say, 2 feet away, and it's a 1 foot piece of paper. So that means the angular size of the paper would be equal to the length of the paper, 1, over the distance of the paper, 2. In this case, I'm using feet, but it doesn't matter. They cancel. Feet, feet. So I get 0.5 radians. Okay, that's the angular size of the picture. Now, going back to the picture. Okay, so I need to find something on the picture that I can identify. And we can't use this whole building because I don't see where the bottom is. So I'm going to use just this antenna at the top. So how big, oh, it's gone. How big is the antenna right there? So I'm going to take this, see, it's a Swiss Army knife, and it has a scale. So I'm going to use centimeters. I'm going to hold this up here, and well, it's hard to see, but I did it, and I got a length on the picture of I got 0.5 centimeters. So the angular size, theta t, of that antenna is going to be is 0.5 radians, and that is equal to the actual length. My pen's dying. Divided by the distance to it. So I can find the distance, r, to the tower is going to be equal to the actual length of the tower, or the antenna, over 0.5. Okay, so this I can get. If you go to the I don't have it up. If you go to the Wikipedia page for the Bank of America in Atlanta, it gives an roof height and an architectural height. So it says the roof height is 284 meters, and the architectural is 312 meters. So the difference between these, I assume, is the antenna of 28 meters. Okay, so that's this distance right here, 28. So then r, the distance to that is going to be 28. Oh wait, I didn't finish this. That's 0.5 centimeters. But I need to get actually the ratio, this is wrong. So theta t is going to be 0.5 centimeters divided by the total length of the picture times the angular width of the picture, which I already said was 0.5. Okay, so now that's 0.5 centimeters. So now I need the total width of the picture. If I assume it starts about right there, and then I can stop at the 6 and do it again, I got 10.5 centimeters. So this is 10.5 centimeters. Centimeters, radians. This pen sucks. Okay, so now I have 0.5 centimeters over 10.5 centimeters, and the centimeters cancel, and I get the answer in radians. So I get, if you put that in your calculator, which I already did because I thought ahead, I get 0.0238 radians. So that is That's not that. So now I have the height, 28 meters, divided by 0.0238 radians. And radians isn't really a unit. So if I divide 28 meters by this radians, I'll get an answer in meters. And this gives me 1176.47 meters. Okay, so a little over a kilometer. That's how far away you are. Okay, now we can look at the map. So if I go down here, we already know the answer. Pretend like you don't know the answer. I could then take the Bank of America Plaza. Actually in Google Maps, you can measure distances relatively easily. But once you know it's 1,000 kilometers, it's 1,000 meters. You can draw a circle around there. Now I know that the Ponce condominium is on the right, so it couldn't be over here. It had to be on this side. You could do something similar with this condominium to get the distance to it, and you'd have another circle. But I think at this point I would say, okay, he's on this circle 1,000 meters away, and there's got to be a park, and so then that has to be it right there. I mean, really, you're limited in this area anyway because you have to have that condominium on the right. Okay, so if you're over there, they wouldn't be on the right. I can do a calculation for that too, but it'd be much more complicated, and I don't have the height of that. So you actually have to look up the height of this, and it gives you the distance, which would be a circular distance, but then you just narrow it down like that. I think that's the best way. If you don't like that, I can do a different way. But that's what I have, and here's the work, and boom.